So till now we have seen that we have assumed k is equals to 1, p, something odd number 5, 7, 5 dot 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 something. We have chosen let's. We have till now we have laid for every lectures we have laid. But actual questions is how to choose the proper k. So this is the main questions. So the questions is how to choose the right k. Okay. Let's just discuss this thing and through an example. I think then it will be better for us. So okay, let's take an example. Suppose I am just draw some our positive points as this color. Suppose let's take this is our positive points, and let's take this is our negative points. Okay, and there are also some kind of there have just first see this thing, and also I have some misclassified point that lie here, and misclassified point that's lie here. Okay, now the questions is, if we choose, suppose let's take we choose our k is equals to so small. Suppose let's take here we choose k is equals to k is equals to 1. I am choosing 1 means I'm just considering our neighbor points only for 1. Suppose we have a point, suppose consider our query point is in, suppose I have taken the query point for white color. Suppose let's take our query point is here. So if we choose our query point is here, actually here, then what happen? Then the k nearest, then k is equals to 1 means so only one neighbor point is what? So for this white query point, our only one nearest point is this one blue point. So actually according to this we have decided this our query point is in this class positive class. Suppose let's take we have chosen this point here. What will chosen? Our if we just choosing k is equals to 1 here, our this the white point, the class of the white point will be what? Actually this is the red negative point. For one nearest neighbor is red color, so this point this class of this our query point now will be red. Okay, so we'll see that by simple using this k is equals to 1, we are by simple choosing this outlier point near the outlier point, we are simple considering this point is also our misclassified. Let's take the same picture. I am just redraw the same picture again. Same kind of picture again I am redrawn. Okay, I'm just redraw the same kind of pictures. Okay, and suppose now here I am choosing k is equals to 1. Now here let's choose, I have chosen here k is equals to 5. If I choosing, suppose also we have some misclassified point is also lie on here, and there have some misclassified point lies on here. If I choose k is equals to 5 actually here, then if we choose a query point, suppose let's take I have chosen here the same type of query point I am choosing here. If we choose in here, then we have to find the five nearest point of this data, because we have chosen k is equals to 5. So what is the 5 nearest point? So our 5 nearest point data is this one, this one, this one, this one, and this one. This 4 data is the 5 nearest point, and the majority of this data, if you see, the majority of this data is actually red. So this thing is easily called a red point, red color point. This called now is easily called a red color point. And if you choose a query point like here, the same thing is also applicable for here for this white dot. if we choose this point here, and if you just using the k is equals to 5, then we have chosen this 5 point, near point. According to this majority vote of this point, then you can easily conclude that this is our this is our positive point, means blue point. This point will be our blue point. Okay, I think you have understand this thing. Suppose just if you asked a 5 years kid, please separate these two data sets. Okay, they can easily draw a say plane like that. They can easily draw a curve like that to separate this plane. Or simple, if you just if you ask a kid, 5 years old kids, to separate this data from blue to red, positive from positive to left, see, they can easily draw this curve like that. In human, just if you visualize this thing, easily anyone can say this is our separations. But the main thing is that if you choose k is equals to 1, just see the our or and just see our green line. If you choose k is equals to 1, then what happen? Then our curve is likely that. Then our curve will be likely that this type of curve. This type of curve we have got on there, like that. This type of non-smooth curve, non-smooth curve. This is a, but actually it is not happen. When k is equals to 1, then we can see our here error is equals to, just see this green curve. Green curve actually means what? Actually we have no mistake here. Okay, no mistakes, no error here we have happen, no error. Okay, but see, when k is equals to 5, then we are simple. If you just see this thing, if we choose k is equals to 5, then we can easily conclude that this query point is not a red point, and also this point is not a green point, because simple of the k, if you have taken k is equals to 5 and we have deciding according to our majority of this thing, majority of our vote. So this curve here, if you just see this curve, our green curve will be like that. This kind of smooth curve here we are getting, this kind of smooth curve. Okay, so here actually here the curve is smooth curve, difference is, and here we have done some mistakes. Actually we have done some errors here, some two errors. Here we have done some errors, but actually here we have not done some errors. Okay, and one thing, just if you call this just is these two kind of things is called actually a decision surface, that we call the plane, that we call the curve that is separated through positive point and negative point. That thing is actually called a decision surface. That thing is actually called a decision. Okay. That thing is actually called a decision surface. Okay, but if you just say, you can call this thing as a curve, but you can call this thing as a surface. But why? Actually, if you just see this thing, you just draw these images in 2D. In 2D surface, I'm just draw this curve. But if you just taking the higher dimensions, in higher dimensions we have not called this thing as a curve in scenario in higher dimension, because we call this thing as a surface. Okay, so decision surface in 3D or higher dimension, hypersurface. In higher dimension we call it a hypersurface. In 3D we have called this thing as a surface, and ND we have called this thing as a hypersurface. and in 2D we call this thing as a curve. Okay, or simple curve or line, any as it. I think the thing is clear, all of you. How if we just increase the value of k, just simple, but just simple from this concept, I think you have clear. If we some increase the value of k, then the smoothness of the curve, smoothness of our curve or surface is increased. Okay, now let's see. So what we'll get, just write down what we'll get. So in knn we get that, in knn we get the smoothness of the decision surface hk increases. Okay, suppose we have seen this thing, if we have taken k is equals to 1, then we are doing no error, means our curve is just like that, we have no mistakes here. Okay, so this is a simple non-smooth curve, we have seen this thing, but actually not happen if you just ask a 5 years or 3 years kid to separate this data, red data and blue data, that is from positive data and negative data, through a curve, then they can easily draw this curve. Okay, but not happen if you take a small k, and if something increase the value of k, then we have seen the smoothness is simply increased. Okay, now let's take, we have taken now on the in the next case we have let's say our k is actually is equals to number of data points n, where n is the number of data points in our training set. Okay, let's k is equals to n, then what happen? Okay, so where n is the total number of points in our data set, total number of points in a data set. Let's see what happened in some cases. So suppose let's take n is equals to 1000. Suppose let's take, we have taken 1000 points, and on this 1000 point we have see our n1 that is positive points is 600 data points, and n2 that is the negative set of data points, that is 400 number of data points. Among this we have total got 1000 number of data points. So 600 data point is positive and 400 data point is actually negative data points. So our n1 plus n2 is actually number of total data points. Okay, let's, so what's see actually here, n1 is greater than is equals to n2. In this case n1 is greater than is equals to n2. If you see this thing, now just simulate this thing through a picture. Suppose let's take, we have this is our positive number of data points. Suppose in positive spaces we have more data point, this is the positive data point, and let's take it is our negative data point, we have less amount of data point. This is our positive set of data points, this is our negative. So in these cases, if we take k is equals to, if we take here k is equals to total 1000, so what happen? So for suppose let's take, we have taken a query point here. Suppose let's take, we have taken a query point here. This is our query point. Let's take, this is our. So what happened? So in this case, we are finding the 1000 nearest neighbor, means for finding or taken, consider, we have considered all the data points to find its neighbors. So from all the data points, so what will be the majority class? So majority class will be here always positive class. So the number of data points is greater than. So what happen? So in such cases, anywhere, just if you take point here as well as here as well as here, so no matter, always from the 1000 query points, from 1000 NNN, from 1000 NNN nearest neighbor, always majority vote will be the positive classes. For this example, or 1000 always the class majority class will be positive classes. That will be our majority class. Because why? Because number of data sets in positive class is larger than our negative. So the number of taken the query point is anywhere on the data set, it's not matter. Its class level will be always positive. So that's the totally wrong thing. Okay, that's because of this every query point. Because of these reasons, if we take k is equals to all n, k is equals to n, so every point, every query point, simple, if you execute every query point will be here positive, no matter it is where in it is classes. So it is totally the wrong thing. Okay, so we see if we just taken k is equals to 1, then we have no mistakes, totally we got the non-smooth curve. This is not correct thing. If we just simple just see k is equals to 1 thing, if we just change this thing, just app slightly move this query point here, the total behavior is changed. So big app, so total behavior means it is actually overfit. For this data, this curve is non-smooth curve is overfitting, and here actually it is underfit. Okay, means here if we choose k is equals to all the number of data points, and this is totally underfit model. Actually we have done mistakes here. Okay, this is, so we have seen that when k 1 2 3 4 we have increased up to number of data points n, when we have increased, then the smoothness of the curves increased, and at final what happened for when a, then we have decided that everything becomes our majority class. Everything becomes our majority class. Okay, you can understand this is not correct, as well as if we take this thing is also, means here we have used the overfitting our data. This is also not correct. We have to choose the right k between them. So because of this k value, because of these reasons, this k is called the hyperparameter. Because of this reason, this k is called the hyperparameter. Okay, because you have to choose the right k to make our model correct as our requirement. It is not overfit as well as not underfit. This thing is called overfit, this thing is called actually underfit. Okay, if we pass something, if we just overfit means if we just doing some changes to our data set, then our model is changes dramatically. We will see how to choose the right k in the next lecture of video. I think how the decision surface works by choosing when k changes, how these things works, how the decision surface changes when k changes. These things you will clear. I think you have cleared this thing. how the value of the k actually depends on our decision surface in knn. Okay, I think clear. Okay, if you have any problem, comment below or please revisit this lecture. I think this is the simple concept anyone can learn, because simple we are calculating the distances. If we just choose k is equals to simple 1, then we are just taken the only consider only one near point, only one. Based on that we have decided. Okay, and a simple, if we choose k is equals to whole data sets, then we are considering the whole point, and only in such cases our majority number of classes will be always our given classes, always. So it is not matter where is our data point, where is our query point lies on our data sets. Okay, so both the cases, both the extreme cases is not true, and so this thing actually we have to choose the right k between them, or to according to our requirement. So these two things is actually called the variance, high variance model, and here actually for where n it's called the high bias models. And the wire between these two things actually handle the wire between high variance and high bias. Actually, the main extreme thing, main thing in the machine learning to make a right model. Okay.